I'm good.
Good. So we doing our the algebra book today?
Yeah.
Okay. What chapter?
I'm gonna go check on my teacher's website, but what we're learning is absolute value equations on a graph.
Okay.
1 minute. So it looks like the chapter will be 3.5.
Okay. Three 3.5 looks to me like it's graphing linear inequalities. In fact, I don't see absolute value on here.
Huh.
But,
You think you put the wrong thing?
well, let's talk about absolute value. Absolute value is actually pretty easy to graph. It's equal, y is equal to x whenever x is positive, and it's equal to negative x. Excuse me, it's equal to x whenever x is negative also.
Okay.
So any
It will never go in the negative.
Yeah, any absolute value graph is going to have this kind of look to it. And the y value will not be above the x-axis unless I were to put a negative sign there, and then that would be reflect everything over the x-axis, and that would look like this.
Okay.
Okay? But it has that same corner in it. And if I wanted to graph the absolute value of x minus 2, well, what is that? That is this function moved which way?
Moved. It would be moved to the right?
Yes, by 2 units. So if this is 2 over here, then the new function looks like that.
Cool.
And you can always check it because you know that when x equals 2, y has to be 0, and that happens right there. In other words, you can check as to whether you moved it to the right or left properly. Notice that had I moved it the wrong way and put it over here, now when x is minus 2, I got minus 2, which is minus 4, the absolute value of which is 4. This picture doesn't fit.
Okay.
So let's see if we can find some problems that reflect absolute value. What about this quiz here? Oh, let me just look at some of these. See, I don't see the words absolute value anywhere in here.
Yeah, I think that might be wrong.
Let me just look at the 3.4, 3.5 quiz, see if they've got any in here. And they do actually have one here. They got a couple of them. Let's graph those. In other words, number 9 and number 10. Let's look at 9. First of all, we need to know what this means. And whenever you have an absolute value equation, always know that it means two different things. We got this or that.
Okay.
So what's the first thing it means?
It would mean
Now, before I go any further, this is an absolute value equation with only one variable. When I was talking before, that has two variables. So this plots in the xy plane as that. If you only have one variable, then it's going to graph along a single number line. Let's solve this, and I'll show you what I mean. So the first thing we can tell is what? 2b minus 1 is what?
2b minus 1 is, okay.
In other words, just remove the absolute value signs for the first part. Second part, the OR part, also remove the absolute value signs. And never mess with what's inside those absolute value signs. But now, for the second part, I have to change the direction and the sign. Now I have two inequalities. Let's solve them both. What happens over here?
Sorry, can you repeat that? I was getting some weird.
Let's solve each one of these. In other words, we ended up with two inequalities based on that absolute value inequality.
Okay.
And we have to solve each one. So let's solve this one over here.
Okay, so you would get b is less than or equal to 2, right?
Uh-huh.
Okay, and then that one would be b is greater than or equal to 1?
Negative 1.
Right.
Notice that I end up with 2b is greater than or equal to negative 2. Divide both sides by 2. B is greater than or equal to negative 1. Now let's graph those on a number line. The reason we're doing it on a number line is because it doesn't fit in the xy coordinate plane. There's no x and y. There's just one variable. This is the B line here. Okay, but it's a number line. We have there and there. So how does my graph go?
So the graph would start, you put b at, oh, sorry.
Let me erase that B. I'm not sure that B is proper there. Let me erase that.
Okay.
So where are we graphing on this graph?
You would put a full circle at 2 going to the left, and another full circle at negative 1 connecting to the line at negative 2.
There's our graph right there. Okay? So when you said graphing absolute value, this is the kind of graphing you were talking about?
Yeah.
Okay.
Well, not really. I was thinking like the f of x equals the absolute value of x minus b.
Okay, that's a little different. Yeah. If f of x, which is the same as y, equals what? The absolute value of what?
X minus c.
Minus what?
B.
Okay, do we know what b is?
No, c. Like the, yeah.
Okay, we just want to graph that?
And then you add d.
Okay. All right. First of all, this is a translation of the elementary function y equals absolute value of x.
Okay.
So here's the elementary function. Y equal absolute value of x. The minus c means it's been what? Shifted which way and by how much?
What was that?
Since they're defining this generically as a minus c, then I would shift it by c amount to the right. And if I were graphing just that, it would look like this. Okay? You with me?
Yeah.
Adding the d means what? What does the plus d do?
It means that you'd increase the y value.
Yeah, it shifts it vertically up. Doesn't change the shape. It just shifts it up by d amount. So now the curve's going to look like this.
Okay.
And that's what your answer needs to look like. Is you've moved it to the right by c amount, and I've moved it vertically up by d amount. So this vertex, instead of being at 0, 0, it's now at c, d.
Okay.
And that would be called the vertex. A little different than the vertex of a quadratic or a parabola, but this is definitely called the vertex.
All right.
So this would be two-dimensional, where I'm graphing the x and the y or the f of x axis like that.
All right.
Whoops. Whatever that's doing isn't good. Oh,
All right.
hold on. I hope I don't have to reboot in the middle. I might, David. My computer's going kapooey here, I think.
Yeah, I'm getting some weird audio mix-ups. It's like cutting out at random moments.
Can you hear me okay now?
Kind of, yeah. Yeah.
Okay. Well, what other kind of problem do you want to try? This other absolute value problem right here, that's got one variable in it only, r, which means that first of all I need to solve it and then I need to graph it, but it would graph on a number line, not on an xy coordinate plane.
Okay. Okay.
So that doesn't look like it's going to have anything that we need in it. I can't get to this. Can't close it out. I can't do anything with it. You try closing it out. Hopefully we can get another 10 minutes in without my computer going nuts, because it'll take 10 minutes for me to reboot, and unfortunately I have a 5 to 6 right afterwards. So what shall we do with our 10 minutes remaining here? Do you have any others that you want to verbalize to me?
Not really. I was thinking maybe we could forgot there was a.
Let me make some up. Let me make some up. And
Sorry.
I'll make them up in 2 variables, okay?
Okay.
But I graphed that. You always want to figure out what the elementary function is. What's the elementary function?
That'd be y equals, yeah.
Okay, they're only going to teach you about 10 elementary functions. This is one.
My teacher, oh, sorry.
Sorry.
My teacher always calls it the parent function, is that right?
What does she call it?
The parent function?
Parrot?
Parent.
Parent function. She calls the absolute value function the parent function?
Like
She, instead of the elementary function, she calls it the parent function. Yes,
yeah.
that's absolutely correct. Okay? So I'm going to, in a dotted line, graph the parent function. Because this function that I gave you is merely a transformation of the parent function.
All right.
How so? Two things going on. What's one of them?
You're multiplying the absolute value.
Okay, we're multiplying it by the parent function by 3, and that has the effect, in other words, if I were to plot just y equal 3 absolute value of x, then it has the effect of making that slope, that's -3 and that's +3. Okay, so it has the effect of making it skinnier. And the way to think about this is that, well, when x is positive, y is equal to 3x, which is this line here. And when x is negative, y equals -3x, which is this line here. Okay? Well, to do a good job of graphing this, we should do the horizontal translation first. What's the horizontal translation? What's the consequences of that inside the absolute value sign?
It's moving to the left 1 unit.
Okay, so if I wanted to graph y equal x plus 1, it would look exactly like the first one, only it would be shifted over 1 to the left. Okay? So that is absolute that is absolute value of x plus 1. 3 times that? That's all you do. And I know the slope on that is 3. The slope on that is -3.
Okay.
Just like the slope on the original one was 1. In other words, y equal the absolute value of x, or x plus 1, has a slope of 1 on it. Okay, now let's talk about negative signs, what their effect is. Best way to do these, I think, is this way. Let's take each translation by itself. What's the effect of the minus sign?
That makes everything that comes out negative.
Right, it's a reflection over the x-axis. So instead of looking like this, it looks like this. It's called reflecting it over the x-axis. And whenever you have the leading negative sign in front of your parent function, that's all you need to do is reflect it over the x-axis.
Okay.
If you have the negative sign inside, in front of, in other words, inside the parent function, that is a reflection over the y-axis. Well, if I take my elementary function and reflect it over the y-axis, it looks exactly the same. I can't tell the difference. And that's the way you graph that. Okay? So we know what the effect of putting a number in front of the function does. It makes it skinnier if that number is greater than 1. If that number is less than 1, in other words, let's put a 1/2 there, then it flattens it out. It makes it like this, so that the slope of this line is 1/2.
All right.
Now, if you put a number inside and in front of that, like that, well, that acts as a horizontal compression. In the same way that when I put the 2 out there, it was a vertical stretch. It pulled everything vertically up. This compresses everything horizontally. So here's my parent function. Well, this has the same effect of a vertical stretch. Compresses it. Think of taking the original curve and pressing it from the left and the right. You would end up with that. And that is a horizontal compression factor. And there's 2 more things you can do. You can subtract a c from it. We already figured out that that's a horizontal translation, right or left, depending on whether c is plus or minus. And then the final thing you can do is add a number outside to the function. And that is a vertical shift. And that's all that does, is it moves everything up or down, does not change the shape.
Okay.
This and this do not change the shape. Horizontal and vertical translations are just shifts. Okay? If I put a number in front of here, that changes the shape. If I put a number inside in front of that x, that changes the shape. But when I add or subtract, I don't change the shape of the curve.
Okay.
And if I put a number like 1/2 in front of that x, well, that has the same effect. That's a horizontal stretch. So now I'm going to pull to the left, pull to the right, and get this.
Okay.
See if I can think of anything else that's like absolute value. Yeah, let me give you one. Hold on a moment. If I were to graph this, it would go, hold on. Let's graph that. That has x-intercepts at, at 2 and -1. So 2 and -1, okay? That is a parabola that looks like this. Okay, that's what that graph would look like. Okay? What do you suppose the absolute value of that would look like? Anything that's in negative territory would become positive territory. So if I were to graph the absolute value of that, that's what it looks like. In other words, the part of the parabola that was below the x-axis gets flipped automatically. In other words, when you have the absolute value of a function, you cannot have any y in negative territory. Y is always positive. So if the original function had part of the function down there, this part here needs to be flipped to there and then erased. So that's the way you would graph a little more complicated function. You're probably not going to deal with anything that looks like this, but I just wanted you to know that if you have a curved function, in other words, if I had a function that graphed, say, like this. You with me? David, can you hear me?
Yeah.
Okay. If I had a function that graphed like this, and then I said, well, graph the absolute value of it, well, all of this has to be flipped. So this little part right here is going to be like that. And this little part down here is going to be like that. And then I would erase that part there.
Okay.
So that's how you graph absolute values. You just don't let anything be in negative territory. And if it is, you flip it over the x-axis back so it's in positive territory.
All right, that makes sense.
Yeah. It's something that's worth knowing for sure. All right. David, I will talk to you next Tuesday at 4:30.
Okay.
All right. Have a good week. Bye-bye.
Thank you.